Today we're going to solve exponential equations and inequalities. So there's two ways to solve exponential inequalities. The first is by equating the exponents. But before we can set the exponents equal to each other, we need to have the same base. So we look at our bases, 4 and 1/2, and we think what common base can they both be written as a power of? 4 is obviously 2 squared, and 1/2 is just 2 to the negative 1. Now, since we have power to power, we can multiply, so we have 2 to the 2x equals 2 to the negative x plus 3. We have to make sure to distribute. And now, because we have the same base, we can set our exponents equal to each other. So we have 2x equals negative x plus 3. We can add x to both sides. We have 3x equals 3. Divide by 3, and x is simply 1. Same thing over here, 9 and 27 can both be written as a power of 3. 3 squared to the 2x equals 3 cubed to the x minus 1. Power to power we can multiply, so we have 3 to the 4x equals 3 to the 3x minus 3. Can set our exponents equal to each other, so 4x equals 3x minus 3. Subtract 3x from both sides, and we get x equals negative 3. Same thing, 100 and 1,000 can both be written base 10. So 100 is 10 squared, and 1,000 is 10 cubed. So we have 10 to the 14x minus 2 equals 10 to the 9x minus 6. So then we can set them equal. 14x minus 2 equals 9x minus 6. Subtract 9x from both sides. Add 2. Oh, I'm sorry, this should be a plus. That should be plus 2. Okay, subtract 2, we get 5x equals negative 8. And divide by 5. X equals negative 8 fifths. Same thing over here. Both of these can be written as base 3. Sorry, this should be 3 to the 4th. 3 minus x equals 3 to the negative 1 to the 5x minus 6. So we can write this as 3 to the 12 minus 4x equals 3 to the negative 3x plus 6. Can set our exponents equal. 10 minus 4x equals negative 3x plus 6. Add 4x to both sides, subtract 6. We get 4 equals x. Now, if we don't have common bases, the way that we can solve exponential equations is to take the logarithm of both sides. So, we're going to take the log with the same base as our number raised to the exponent in order to cancel things out. So we have log base 4 of 4x equals log base 4 of 11. Like I said, we're just going to take log base 4 of both sides. We know by our properties that cancels out, so we just have x equals log base 4 of 11. Same thing down here, we can take log base 2 of both sides, because we want to get our 2 to cancel out. So then we just have x equals log base 2 of 5. You'll notice that this is simply the logarithmic form. However, this will be easier when we do inequalities, and it'll make a lot more sense. So we're going to continue to do it this way. So this one we're going to take log base 7 of 7 to the 9x equals log base 7 of 15. I'm going to take it on both sides. We get 9x equals log base 7 of 15. We're going to divide both sides by 9. So we know that x equals log base 7 of 15 divided by 9. And then on this last one, it's so much easier if we simplify this first. So we can add 7 to both sides, divide by 4. E to the negative 0.3x equals 5. Now we can take log base e of both sides, which is the same as natural log. This cancels out, so we have negative 0.3x equals natural log of 5, and so we can just divide by negative 0.3x. or negative 0.3. And that's our answer. Now you'll see, once again, I said it was going to make more sense when we did inequalities. So in order to solve the inequalities, we're going to do the same thing as we did with the equations. We're going to take log base 3 of 3x is less than log base 3 of 20. I apologize, my smartboard's a little crazy. And then we know that x is less than log base 3 of 20. Well, that's all we have to do. Now for number 2, we're going to take log base 10 of both sides, which is just log. So this cancels out, so we have 2x minus 6 is greater than log of 3. We're going to add 6 to both sides. We're going to put it first, so that way we know it's 6 plus the log base of 3 and not the log base of 9. And then we're going to divide by 2. So your answer is simply x is greater than 6 plus log 3, all divided by 2. And then for this last one, we're going to take log base e of both sides, which is just natural log. And so then this cancels out, and we just have x is greater than natural log of 2.